Hi, I'm Miss Fu, and today we're going to look at linear equations, angles of inclination, or in other words, the angle between the line and the positive x-axis. Let's have a look at this graph over here. Here we have the setup to describe the gradient. We have the rise, y2 minus y1, and the run, x2 minus x1. And we can calculate it using that formula over there. And that would give us the same gradient as saying rise over run, which is 2. And we also notice something. If we put the angle in this right angle triangle, then that would be the opposite and this would be the adjacent. And O over A, that would be tan theta. So tan theta would be equal to O over A, and our O is y2 minus y1, and our A is x2 minus x1. So in other words, tan theta is equal to our gradient. So we can use that, our gradient being 2, we can use that to find what theta is. So theta equals in tan inverse 2, which is 63.43 degrees. So we notice that if we move the angle down here, it is the same angle. Or in other words, to find the angle between the line and the positive of the x-axis, all we have to do is to find the tan inverse of the gradient. So one more time, to find the angle between the line and the positive of the x-axis, we find the inverse of the gradient. So for this graph, the line makes an angle of 63.43 degrees with the positive of the x-axis. Let's try a couple more examples. Find the angle between the line and the positive x-axis, so the angle we were talking about. So for this one, let's find the gradient, so rise of 1, run on 2. So 1 over 2 is our gradient, so tan inverse that to find theta or our angle. So our angle that the line makes with the positive x-axis is 26.57. Example 3. This one's a little bit tricky, so pay close attention. So here we have a negative gradient, minus 3 over 1 is minus 3. But when we're doing tan theta, we're looking at opposite over adjacent, and the length of the opposite here is just 3 and the adjacent is just 1. So we're just looking at the positive of the gradient. Be very careful. So when we plug in the calculator, you're doing tan inverse 3, not tan inverse negative 3. Now when we do that, we get a value, and that value is the angle of this triangle here, which is in here. So opposite of adjacent makes that angle there. But what the question is asking for is the angle between the line and the positive x-axis. So that's the line. The positive x-axis is going this way. So we want that angle, because at the moment theta is the angle between the line and the negative x-axis. So how do we find the angle that we want? Well, we can see that that's 180. So all we have to do is take 180 minus theta, which is 108.43 degrees. So just to recap, whenever you see a negative gradient, you must take the tan inverse of the positive of the gradient, but then whatever value you have to subtract it from 180 to find that angle over there. You might want to write a couple notes here. So pause the video, write that full bit of explanation in your own words, and then unpause when you're ready. So when the gradient is negative, find the angle of the positive and subtract it from 180. Example 4. Find the gradient between the 2 points minus 1, 7 and minus 4, 3, and the angle that the line makes with the positive direction of the x-axis. So let's find the gradient. So 3 minus the 1 over minus 4 minus minus 7. Be very careful with your negatives. 3 minus 1 is 2 over minus 4 minus minus 7, which is plus 7, is 3. So there's our gradient. Now we have to find the angle, so tan inverse that, and we get 33.69 degrees. And because it's a positive gradient, we are done. Example 5. Find the gradient between the 2 points 1, 4 and 9, 2, as well as the angle that the line makes with the positive x-axis. So again, let's write down our gradient, 2 minus 4, and then over 9 minus 1. 2 minus 4 is negative 2, and then 9 minus 1 is 8, which simplifies to be minus 1 over 4. This time we have a negative gradient. So let's tan inverse the positive of that to get our theta. And because it's negative, we have to 180 minus that, which gives us that value over there. Try using the calculator to see if you get the same value. Example 6. Find the angle that the line 2y minus 3x equals 4 makes with the positive direction of the x-axis. So here we have the equation. All we have to do is rearrange to find what m is. So 2y minus 3x equals 4. Let's move the 3x to the other side. It becomes positive. Then divide by 2 on both sides. We have y equals 3 divided by 2 is 1.5. And then 4 divided by 2 is 2. So our gradient is 1.5. Now tan inverse that and we get our angle to be 56.31. That's it from me today. Make sure you use the calculator and practice finding that tan inverse button. And check that you have the same answers. I'll see you next time. Bye!